Hello, everyone. Welcome back. Today, we're going to do a review of common factoring. So, essentially, what we need to do here in each example is find the greatest common monomial factor and factor it out of every term. So, how can we do that? Well, there's two elements to all of these. There's the coefficient. So, we have to look at the coefficients of the terms and figure out what the greatest common factor is of those coefficients. And then we have to look at the terms with variables and see if there's what the greatest common factor of those is as well. So let's start with example A. It says 4x plus 16. So what are the coefficients, or in the case of 16, the constant? Well, those are numbers are 4 and 16. The greatest common factor between 4 and 16 is 4. So that means I'm going to write a 4 here. Then I need to look at the variables. Now, the thing is, only one of these terms has a variable. 4x has the variable x, but 16 is a constant and doesn't have any variables. So therefore, we actually can't factor out x or any power of x from both because only one of these terms has that in the first place. And so therefore, the greatest common factor between 4x and 16 is 4. And then I'm going to put brackets and write our inner terms. So 4 times x would give us 4x, so x goes here, and 4 times 4 is 16, so 4 goes here. And if we were to expand this, keep in mind, if we were to expand this back out, we'd get 4 times x, which is 4x, plus 4 times 4, which is 16. Because essentially what we're doing when we're factoring is we're just changing the format of 4x plus 16 or whatever it is we're factoring. We're not actually changing the values, right? We're not actually changing the meaning in that sense. We're just manipulating this equation in order to change the way it presents itself, right? We're presenting it now in a factored way instead of an expanded way. Okay, let's do the same with example B. Let's first look at the coefficients, which are 10 and 20. What is the greatest common factor between 10 and 20? Well, that's going to be 10. So I'm going to write 10. And then what about our variables? We have x squared and x as the variables. So the greatest common factor between those is just a single x. So I'm going to put a single x here. And then I'm going to find what we need for our brackets. So 10x times what is 10x squared? Well, 10x times x is 10x squared, so I'm going to put an x here. And then 10x times what number is 20x? Well, 10x times 2 is 20x, so I'll put plus 2 in there. And again, if we were to expand this, we would get our original question back to us, which is what we want. So you can always check if you factored something correctly by just expanding and ensuring that you get the same as the question when you do that. Okay, let's do C. So for C, we have 2 and 4 as our coefficients. So the greatest common factor between those numbers is 2. And then for variables, we have x to the power 4 and x to the power of 3. So x to the power of 3 is the greatest common factor. So there we go. And then we have to find out what we're putting inside our brackets. So 2x cubed times what will give us 2x to the power 4? Well, that's just going to be x to the power 1, or x, because recall that whenever we multiply exponents together that have the same base, we add up the exponents, right? So if we have x to the power of 1 times x to the power of 3, those multiply and make x to the power 4, right? We add the exponents up when we multiply those values. Okay, and then we have 2x cubed times what number will give us negative 4x cubed? Well, that will be times negative 2, like that. And there we go. Okay, let's try D. For D, the coefficients are 17 and 3. Now, both of these are prime numbers, and so actually there's not going to be a greatest common factor between 17 and 3 other than 1, and so we can actually skip that part. What about between x cubed and x squared, though? Well, the greatest common factor between x cubed and x squared would be x squared, so I'm going to write x squared. X squared times what is 17x cubed. Well, x squared times 17x would give us 17x cubed. And then x squared times what is 3x squared? Well, x squared times 3 would be 3x squared. So that's what we can put in our brackets there. Okay, great. Let's do the next one, E. We have 6x squared minus 15x. So what's the greatest common factor between 6 and 15? Well, that would be 3. So I'm going to put a 3 here. And then greatest common factor between x squared and x would be x. 3x times what is 6x squared? Well, 3x times 2x is 6x squared. And then 3x times what is negative 15x? Well, 3x times negative 5 would be negative 15x. And there we go. All right, well, we're going to expand into even more different factoring methods for different things in the future, but this is how we common factor. And oftentimes, common factoring can be the first step in solving a larger factoring problem, so it's definitely good to review that as well. As always, feel free to leave any questions about any of this in the comments, and I will see everyone for the next one.